Okay, good afternoon. Yes, we can get it back if you don't mind. So at this point in our lives, we had some homework, not so? The homework was on page 20? 20. You had to do exercise 8, correct? Number 4 and 5. Any issues there? Any other issues? Only number 5. Okay. Page 20, exercise 8, number 5. Exercise 5, no? 8. Sorry, man. Alright, so the question says evaluate or calculate, whatever. Okay. Where do we start? First three terms. Let's do the first three terms. So the first one is going to be 2 cubed, not so. The next one? 3 cubed. The next one? 4 cubed. So what am I shorting for the sum itself? How many terms are here? 5 minus 2? 3 plus 1? 4. I've got 3 terms. So just add the 4th term. 5 cubed. So what you did was you wrote 827, then you wrote 64. And you were trying to work out the sum of terms. But remember that these numbers here, 8, 27, 64, those numbers does not conform to a pattern that we're familiar with. For the sum of formula, what we use? We use the arithmetic, which is not the case here, or we use the geometric, which is also not the case. You understand? So since it's just going from 2 till 5, so it's a little terms, not a lot of terms. So you just work out all the terms, and then from there, you just add. What do we get when we add this? 220? 224 or 5? Doesn't make sense, people. Okay. Then I gave you work from the revision exercise, okay? So that we will leave for the next lesson. Okay, I'm not here tomorrow, so I'm going to add a homework to that revision exercise. Okay, and that is going to be for Thursday. I'm not here tomorrow for tomorrow's lesson. So I'm going to give you homework for tomorrow's lesson. So during the lesson, whoever is here substituting you guys, supervising, you do your maths, okay? And that can happen for any subject. No? They're supervising you. You must be practicing maths often now. You want a good mark in maths at the end of the year. It's not going to come easy. It's easy to pass, to get 30%. It's not going to be easy to get the A or whatever. Okay? So it costs you a lot of time and so on. Okay? But I'm sure you guys can do it. Others done it in the past. And you guys are much better than them, isn't it? Yes, good. Did the person get back from the toilet yet? Who went to the toilet? Sorry? What? Still not back. As soon as you get back, you can go. I don't want the teachers to catch us walking around and they put you in detention. Right, so yesterday we've dealt with example 1. We did example 1, 2 and 3 yesterday, not so? So now we're going to look at example 4 on page 20. Example 4 on page 20. Go. Go friend, you must sanitize. Okay, sorry about that. So, example 4 on page 20. So the question says evaluate each of the series below and express the result as sigma notation. Okay. No, it's a pleasure, miss. They could have said instead of evaluate, they could have said calculate, or they could have said determine the value of the series or whatever. As I mentioned before, that evaluate, calculate, determine simply all means the same thing. Okay. So to write something in sigma notation, remember what do we need? We need the starting point, the value of the end point. We need the general term and the sum of terms. That's what we need. Now, so if we start, okay, so I'm going to put it here. If we start, we'll always start with n is equal to 1. If we have a choice, we always start where n is equal to 1. And always when they ask you to write it in scientific notation, we start off with n is equal to 1. Okay, you guys understand? The ending point, okay, the general term. Can I derive the general term from here? Yes, I got the first 3 terms. Not so? So I want you to determine the general term there. Then you see the general term equal to negative 279. Then by that way I would have calculated how many terms there are in the sequence. Or in series in this case. You all agree with that? Then with that I can calculate the sum of the terms. Why? Because my Sn is equal to n over 2 into a plus l. I would have had n at this point, the number of terms. I have the first term which is 12, and I have negative 276 as the last term. You guys understand? Okay, so do that quickly. We're going to work on the general term, the number of terms in the sequence, and the sum of terms. I'm going to pause the video at this point. Okay. Okay, at this point you should be done. So, first 3 terms. So the general term would be Tn is equal to a plus n minus 1d. So what's the general term? 2l plus n minus 1 times negative 8. So it's negative 8n plus 8 is going to be plus 20. Not so? So here goes negative 8n plus 20, which is your Tn. Are you all okay with that? Right. Then we said you're going to set Tn equal to negative 276. So in other words, negative 8n plus 20 equals negative 276. So negative 8n is equal to negative 296. If I divide that by negative 8 both sides, n works out to be 37. So there are 37 terms in the sequence. The ending point is 37. Does it make sense? Yes. Then the question was to work out the general term, the sum of terms. Do I have the last term? Yes. So I can use Sn is equal to n over 2 into a plus l. How many terms are here? 37. So it's 37 over 2 into a 12 plus negative 276. They give me an answer of negative 4,884. Alright? You all understand? Any confusion? No. People? Let's try number 2. Again, I'll give you a few minutes to try it on your own. It's also on page 20, okay? What do you notice with regards to this sum? If you're going to write this in sigma form. What's your starting point here? 1. Ending point? Infinity. Not so? So on top you're going to write infinity. So when we work out the sum of the series, we're going to work out the sum to infinity. Okay. Don't forget. Again, it's in this form. End point, starting point, general term, and the sum of terms. In this case, it's going to be the sum to infinity. Okay. You all okay with that? So we're going to start with n is equal to 1. We're going to end by infinity. As you can see, the sum is carrying on forever. The general term is going to be Tn is equal to AR, n minus 1. What's my A value? 100. My R value? 2 over 5, raised to the n minus 1. And is equal to Sn, or S infinity in this case. So S infinity is equal to A over 1 minus R. Your A value is 100 over 1 minus 2 over 5. So that's going to give you 3 over 5. It's 500 over 3. Is that correct? That's going to be 500 over 3. That's the answer that you're looking for. Any confusion, people? You all okay with this? You all understand? Right, let's do another one. This is example 3. Here we go. So now we're not going to tell you what to do. Let's see if you can unravel this yourself. Again, the question is to write in scientific notation. Alright. I'm going to pause the video at this point. So at this point you guys are done. So again, we start off with the first term, n is equal to 1. That's the first 3 terms, so what's my general term? Tn is equal to AR n minus 1. Not so. What's your A value? 5. Your R value? Negative 2. Not so. N minus 1. Okay? So it's 5 into negative 2, n minus 1. People, that will never multiply. Yeah? So now we say that Tn is equal to 5120. So in other words, 5120 is equal to 5 into negative 2 n minus 1. So what do I do first? Divide by 5. So we then get negative 2 raised to the exponent n minus 1 is equal to. There's going to be 1, 0, 2, 4. You see this base is negative here. The only time this base will be negative is when? The only time that this basis can be negative is when people, the exponent is, that will result in a positive solution. When the exponent is, what? Even, yes. Okay, not some, why? Because if the exponent is even, the number will be positive. Not so. So 2 to what exponent is 1024? Huh? 10 to the exponent 10. So what can I conclude now? Therefore, n minus 1 is equal to 10. So n is equal to 11. Yeah, 11 now. Not so. So what still needs to be sorted out? Sn. Not S infinity any longer. Sn. So the sum of geometric sequence is what? Sn is equal to A or n minus 1 over r minus 1. So I'm going to work out S. 11 equals 5 into negative 2 to the exponent 11 minus 1 over negative 2 minus 1. Let's put that in the calculator. We've got 5 open brackets, negative 2 squared. No, the exponent 11 minus 1 over negative 2 minus 1. The answer 3415. 3400. 3415. 3450. You all agree with that? Yes. Any confusion? Any confusion? No. Right. The last one of this type. Sample 4. Whoops. On page 20. Pause the video again at this point. So, what do we notice here? It's quadratic. The second, there's a quadratic pattern. So what would its general term be? Starting point, n is equal to 1. How many terms are here? 5, 6, 7. The general term is quadratic. So Tn is equal to an squared plus bn plus c. Not so? Or it's just simply n squared. Not so? So there we go, n squared. What does the sequence add up to? Sorry? 142. 114. Oh my word. Okay, so 14 is 20 is 30, is 55, 55 is 85, it's 91, 91 is 100, 140. What did it say? Are you so insecure of your answers? What? You can't even say yes or no. You know why you guys are getting maths together? I thought, the other class students in the other class will start talking to me. For those of you who were here last year, you guys didn't talk to me. No? So I made sure that we get other people that I thought would have spoken to me. But clearly, you guys don't want to talk. You must talk so that I can gauge if you understand or not. Don't give me a shock every time in the exam. No? You're shocked. You get the shock of your life. Right. You guys understand? Oh my words. Alright, so that basically brings us to the end of the examples pertaining sigma notation. Okay. So for we're going to do now exercise 8 number 1. Okay. Exercise 8 number 1. And this is on page 20, I think. Page 20. Number 1. Alright, so for homework I want you guys to do number 2 and 3. Part of your homework for tomorrow's lesson, since I'm not here, I want you guys to work on the following. I've already given you from the revision exercise, I gave you number 1 to 4, no? I want you guys to do number 5 to 8. Okay, and that is for Thursday. So during the lesson on Thursday, you tell me what the issues are, and then we can sort out what numbers 1 to 8 on Thursday. Okay, inclusive of exercise 8, the current exercise we are busy with. Those sums I want you to wrap up as well. Okay, you guys know what to do, no? So the remainder of the lesson we're going to work on exercise 8 number 1. If there's time left, we'll work on number 2 as well. Okay. Don't have to write down the sums all the time. Okay. Okay, at this point I take it you guys are done. Right. So given the series 2, 9, 16, all the way to 331, determine the formula for the nth term. So for the nth, so Tn is equal to a plus n minus 1d. Not so. What's my a value? 2 plus n minus 1 times 7. So that's going to give you 7n minus 7 plus 2 is minus 5. You all agree with that? 1.2. Express the series in sigma notation. So your starting point is 1. Your ending point we will calculate by setting this here, which is 7n minus 5, equal the last term, which is 331. So it's going to be 7n equals 336 divided by 7. 336 divided by 7. 48. Not so? So there are 48 terms in the sequence. Okay? The general term is going to be 7n minus 5. Not so? Now they ask you to calculate the sum to the series. Okay? Previously, we calculated prior to that, but now they're asking you. So to calculate the sum to the series, it's going to be Sn is equal to, which one of the two are you using? A plus L, not so? Why? Because I got the last term. If you are going with Sn is equal to n over 2 into 2a plus n minus 1d, you should get the same answer. Okay? So this is going to be S, 48 equals 48 over 2 into a, what's your a value? 2, and the last term is 331. So that gives us an answer of 7,992. You all agree with that? So do you have to write it here? No, you don't need to. You don't need to, because this question came afterwards. Okay, so what was your question? Is it this year? What were you confused about?
I thought you had to write it out in series.
Why are you going to write it out in series? Because there's the series itself. Given the series, that's the series. Okay. Any other confusion? You will understand? Do you think there's time for one more? Or we're going to stop here. I knew you were going to say that. Yes. I'm going to ring now. You got like 5 minutes, 6 minutes. You got to have done 5 sums in that time. Right. So we'll call it a day at this point. Don't forget during tomorrow's lesson, when the individual supervise you, no? You must do that work I gave you, okay? People enjoy the result. You must start today with it. Otherwise, you're not going to finish it in the lesson tomorrow. Enjoy the rest of your day. Good afternoon, class.